Today's author and researcher Paul LaViolette, and we actually have met before at a conference in Bosnia, and fascinating guy. We had lunch together. Paul is one of the greatest minds in this alternative research, and fascinating to have him on today. I don't want to get complacent. A little bit about today's author before I bring him on. Paul LaViolette, PH.D. He's the author of Secrets of Antigravity, Propulsion, Subquantum, Kinetics, Earth Under Fire, Genesis of the Cosmos, Decoding the Message of the Pulsars, Galactic Superwaves and their Impact on Earth. He's also the editor of A Systems View of Man. He's also published many original papers in physics, astronomy, climatology, systems theory and psychology. He's received his BA in physics from Johns Hopkins, his MBA from the University of Chicago, and a PhD from Portland State University. Currently the president and director of the Starburst Foundation. You can find that website starburstfound.org, and you can read about Paul's bio and on his other website, the etheric.com. That's ETHERIC, etheric.com. Without further ado, let's bring on today's guest. Hi, Paul. First of all, you're very welcome to the show.
Hi, how are you doing?
Good, Paul. Great to see you again. We met at the conference in Bosnia. I had been aware of your work before from a couple of people who brought it to my attention, and I found it fascinating with the galactic superwaves, and I know that's been a heavy hitter as well, and across the board. I guess, Paul, I mean, it's not the normal branch for people to go down in physics, and if people want to check out that interview, you can go to Paul LaViolette, Capricorn TV, you'll find that, Paul's presentation. But, I just found something really deep and meaningful in your work, Paul, and I know that you have a great mind the way you look at it, and there's not a lot of people take on this subject matter. I guess tell us a little bit about you, Paul. Why physics? Why? I always want to know about a physicist. Why does a physicist jump into the physics? It's always interest to me. What inspiration? What encouragement? What support?
Well, when I was very young, I was just curious about everything, existence, the whole thing, and that's what I thought physics would teach you, was to understand the physical world around us. And really, probably what I was aiming at was what I got into later, which was system theory, because system theory deals with everything. It combines science with philosophy almost. And the system theory has made great advances in business, sociology, life sciences, across the board.
It doesn't discriminate.
When I got into physics, I was disappointed, actually, that, they were focusing, a lot on theories of what was happening at a level they couldn't even see. And it wasn't really giving very satisfying explanations to me. And that's when I started searching outside physics for other ways of looking at things.
Sure.
And finally ended up in systems theory.
I think there's something awesome about. I worked as a systems analyst, but mostly in an engineering place, and I know we talked about that, Paul, in Bosnia. But I just love what that. It took me a long time to get there. I elevated myself to that, and I know exactly what you're talking about, Paul. It seems bizarre that we have these compartmentalized subjects where we look at a very narrow window and we think we're the greatest expert in that, and we're sometimes missing the good stuff, or we're missing the big part of the puzzle. And, but like I say, there's very few people want to rise to the challenge of a systems theory, because you have to have a spectrum that's very big, Paul, or a knowledge base that's very big as well.
Yeah. Well, this is a core idea in systems theory, is to try to become more interdisciplinary. And that's what systems theory does, is takes ideas from one field and brings them into another, because it gives you a framework for doing that. And we find, like, for example, years ago, they thought that the human body operated like a machine. And eventually, as science advanced, they found, well, we're biochemical systems. And, the same for business organizations. At one time, they sort of directed businesses as if they were military organizations.
Yeah.
And then with system theory actually made inroads into the theory of businesses, and they started looking at them as organisms.
Wow.
Competing,
self-organizing.
Sort of the same principles that operate for cells and for living organisms can be applied to businesses. With physics, it's sort of like stuck in a time warp in the past.
For sure.
It's like froze, like in Matrix, they froze everything.
Yeah.
And the real advances have gone forward in black projects, secret projects that we have no idea about unless there's some leaks here and there.
Yeah. I want to get into some of your recent projects too, but just on that point, Paul, do you think when there's black projects going on, that these guys have got the free reign? They're the real think tank. They're just given the big budget and the free reign to go and explore whatever they want.
Well, I can't really say.
Speaking only speculate.
But I imagine that's probably could be close to it, what you're saying.
Sure. You're currently working on the Nasica's thruster rocket as a replacement for normal rockets. Paul, you got to tell me about this. Expand on this. This is pretty revolutionary, yeah?
Yeah, well, Dr. Nasica's a physicist, was a professor at the Technological Educational Institute of Thessaly, it's called now. He's now retired. He had been experimenting for 10 or 20 years on propulsion ideas and stumbled on this device that's a superconductor. It consists of a superconductor and magnet that develops a thrust when you cool it.
Wow.
You have to use nitrogen to cool it down. So you're familiar with maglev?
Oh, yeah.
There's like a train in China, Shanghai, that runs on maglev, and that works by having magnets in the rails pointing up, and then on the train they have this superconductor, high-temperature superconductor, that they cool down. And when it becomes superconducting, it's able to repel the magnetic field of the magnet, so it develops a field opposite and is able to levitate the train. So what Nasica's had developed is a way of putting that magnet on the superconductor itself so that it, as a unit, can propel itself through space. So if you were to take it out in space where the temperature is can be 40 degrees above absolute zero.
Wow.
It would just accelerate and eventually reach the speed of light if it went far enough. And we've built and tested this. It's a very small thrust, but it's already it's 1,000 times better than what NASA used to go to Ceres with the Dawn spacecraft. Dawn spacecraft used what's called an ion
propulsion system, yeah. So it's 1,000 times better than an ion propulsion system.
In terms of the thrust per unit mass.
Yeah.
Because the ion propulsion system has to take with it 0.5 ton of xenon propellant.
That's the drawback.
And plus it needs solar cells, so the weight of the solar panels. And then the thruster itself weighs 15 kilos. Wow. So by the time you add up all that, and
there's a lot of momentum to get that up. So basically the ion propulsion system, it puts out an ion beam and it slowly but surely builds up momentum until it's...
Right. It would never get off the ground from here, but you see they build it out in space. And it's able to, with such small thrusts, they can get out there, but it takes 7.5 years. With Nasica's version, he has no propellant, so the thing weighs, compared to over 0.5 ton for the thruster system that they use at NASA, his weighs, it'd take 5 of his thrusters that we test to equal the thrust on the Dawn spacecraft. And that comes to around 600 grams is all it weighs. So
whoa. That's a big difference.
Per unit mass, his develops 1,000 times more.
That's crazy, Paul.
But it needs no power. because it uses a permanent magnet. Now, the one we're working on that we're looking now for funding it's going to completely change the world if it works. And we believe it works. We've done calculations, the physics, the equations for interaction of electricity and magnetism indicate that it will produce this force. It's whereas the first one worked on what's called a Meissner effect, which is the maglev. This works on a slightly different force. It's called Lorentz force.
Lorentz law, yeah.
And it involves a coil, just a superconducting magnet coil like they use at CERN for their particle collider. But he designs it a little differently. He has it in a conical shape. And according to our calculations, it should develop a thrust towards the narrow end, and really quite a big thrust. Because you have like tens of thousands of amperes circulating in the coil being superconducting, and it's generating fairly tense magnetic field. So to build and test it, we're still waiting for the quote from the company.
It's that big, Paul, is it?
It probably won't be cheaper than $20,000, So,
but still, that's not a lot, Paul. That's not a lot in terms of what you're asking to build. I mean, it's like something radical and revolutionary.
It's a lot for us, It's a
lot when you don't have it, but
Social Security checks. Both of us, are. We don't have a funded company at this point, just an idea that's patent is applied for. Sure. But with something like Indiegogo, which is
we'll put an Indiegogo campaign up for you, Paul, at Capricorn Radio. I'd be glad to help. We'll sort with that for sure. We'll help along with that. And I know this is the beautiful thing about alternative research is now, Paul, it's in the hands of the people that can help. It's people listen to shows like this and, they follow along, they read books about these authors. And 20 years ago, the paradigm wasn't there, Paul. There wasn't a genre there. And the internet's changed everything, You're able to reach out to people like this. So, but this is revolutionary. I mean, where are we at with the superconductor technology? I mean, the superconductors, getting the temperatures down. People want to have a superconductor at room temperature. That's the ultimate. But where is the superconductor technology at, Paul? Is it any way advanced yet?
Well, they keep improving it. There's one company here, not far from where I live, that produces superconducting wire that it's revolutionizing power, transport of power. It's able to be superconducting at liquid nitrogen temperatures. Wow. Which liquid nitrogen is actually quite cheap. It's only about 10 cents a liter.
Yeah.
And most towns have liquid nitrogen stations for refrigeration trucks, for example, where they can fill up. So, the thruster that he's developed, it works better on liquid helium. It develops 3 times more thrust than liquid helium, but for practical use for, let's say, an automobile, a flying car, for example, you have 3 of these thrusters or so under your car. You just fill up with liquid nitrogen, and then you'd energize the coils, so power them with a what's called a power supply. Once you get the things powered up, then you can shut off the power. So, you get transportation with no power input at that point. All this stuff, of course, breaks the laws of physics, but superconducting coils, in a way, they break the law of physics. They operate, create a magnetic field. Yeah. Without power, even though it's electromagnets.
I'm glad you mentioned the laws of physics, Paul, because like you say, we're stuck in this time warp, and let's talk about Newtonian physics. Let's talk about the crossover with the Solvay conference in the 1920s and the quantum physics then I mean, it just changed the paradigm for us then. And the last 100 years almost, 90 anyway, since the Solvay conference, we've been stuck in this weird quantum world where we don't really get it, but we do. We're stuck in we do the math and we do the equations, and it's hard to grasp. I mean, physicists will tell you we don't really understand it. I mean, how many people really do understand quantum physics, Paul? I mean, it's that the math is extremely difficult, and it takes in so many weird branches. I know, and I tell this to people, that the tracks on a mobile phone are so narrow and so close together that they can only make them so close because the electrons will get confused. They'll be, in either wire, and you have the tunneling effect. And, we're limited by the quantum world in an engineering sense. And we know how to out-design this in an engineering sense and to apply quantum, but we don't really get it. We're still stuck in that time warp, and it's a quantum thing.
Yeah. You can think of the ideas of physics as sort of like a roadmap for us to understand the real world.
Yeah.
And it gives us a framework for sort of understanding what's out there and being able to develop technologies and so on. Even though it might not be correct,
yeah.
It's still, it's a framework which has a certain amount of applicability. It's just that the applications are in certain areas, and other things are considered impossible in the current framework, and so they're not done. And so things like levitation devices, they're not seriously looked at, except now NASA is starting to look at devices that challenge, for example, the Newton's third law. They're called reactionless propulsion devices. In fact, they use a reactionless propulsion engine on the International Space Station and on the Space Telescope to aim it. They're called control variable gyroscopes, I think.
Wow.
They're mechanical devices. They're able to create a thrust to turn something without having anything to work against except space itself. And
really?
When you come down to it, that violates Newton's third law, that every action requires a reaction, because they're getting action without reaction to do that.
I like the way you explain that. It's like when whether you're talking Newtonian physics or quantum physics and either physics of the ether, if you like. It's like we have these constructs that we're tied to, and it seems like we have this anthropomorphic perspective on how we go about business, when realistically business should be business. It should be, explore all physics, and we have these rule sets that we've narrowed ourselves into. And it's like, wow. Do you believe in the ether, Paul? You've got your
physics that I've developed is based on the ether.
Can you explain that to the audience? Basically, what the ether is, how it can be tapped into, or exploited, or used, or manipulated, then for the purpose of energy or something like that.
Well, the ether is a substance that's below the quantum level that you could. In the 19th century, they thought of the ether as something that surrounded material particles, but was part of material particles, which I believe is a wrong idea. The ancients and the alternate version of the ether, I think there was an alternate version in the 19th century that had the ether actually making the particles also. So it would be then everywhere, and all matter and energy would just be waves in the ether. And so think of us as, if you ever seen a sheet of paper with a watermark on it, it's all paper. It's just the paper is configured in a little different way where the watermark is.
Sure.
Think of the physical world as just a watermark in the ether.
Wow.
So our real substance is ether. We are the illusory world, and this is the way in ancient Sanskrit writings they speak of the idea of Vishnu, when he awakens, the physical world dissolves, and we all realize we are Vishnu that was dreaming, and the physical world is a dream that. And you probably heard some of the Joseph Campbell lectures about this.
I have. Well, I've also spoke to Michael Cremo as well, and I've done a few shows on the Sanskrit writings, and I think they're incredibly, at the very least, very incredibly interesting, but at the best, I think they're incredibly insightful of some ancient knowledge too.
Yeah, in fact, the physics I developed, which was based on system theory and modern findings in physics, actually later I discovered it had roots in ancient times and was actually metaphorically encoded in certain ancient creation myths. In the sense they felt it was so important, they wanted to convey it to the future, like in time capsule messages.
Gotcha.
Which is complete, mind-blowing concept in itself. And I wrote about that in a separate book called Genesis of the Cosmos, where I go analyzing various lores, ancient Egyptian myths, ancient Greek, the Tarot, even the zodiac, encoding this physics. The zodiac, the idea that dates back thousands of years.
That's one thing you can see the zodiac in the wall behind you, as you see, Paul. But that's one thing I remember about your speech in Bosnia at the conference, Paul. That's how sophisticated the mapping of the zodiac was and the system of knowledge that they encoded and left for us. It's so sophisticated. If you want to just mathematically lay it out, but I remember you saying that the civilization that mapped that had something parallel to our own. At least in terms of the fixed stars it's just a massive.
They knew where the center of the galaxy was located. They were making photos for us. They knew where the hot and cold regions of space are. It's in the 3-degree Kelvin radiation that we needed spacecraft to go up there with helium-cooled sensors to find that. We needed computers to process the data to find that. And they knew it, and they marked it out in the zodiac, and they encoded it with the temperature encoding. So they associate the signs with certain planets, which the temperatures are different on each of the planets. If you map that out, you find a temperature gradient going from hot in Leo to cool Aquarius.
Sure.
And the same for the body parts. Leo is at the heart, which is the highest temperature part of the body. If you look at medical data, I went and got all the medical data about body parts, and I mapped it out, and sure enough, then Aquarius is the feet, and Pisces the ankles, or do I have it correct?
I can never remember which one it is. I'm Cancer, by the way. I know I'm the lungs and the breasts, so I can't remember it.
And we have the expression cold feet, so... this is just an example, but actually the signs, the zodiac signs, encode these basic concepts of how order emerges from disorder. Whether it's applied to physics or some other field of science, it's something that we just discovered in the last 50 years. This is the kind of stuff that Prigogine was working on, Nobel laureate Prigogine. His group in Brussels, and they also did work in Austin, Texas. They were interested in studying, like, for example, reaction to fusion systems that would spontaneously organize ordered patterns, because they felt that this would give us an insight into living systems, which do this. They are, living systems are creating order spontaneously in a way, which puzzles physicists because they have their second law of thermodynamics that says that order should go towards disorder, the idea of decay. And yet living systems challenge this. And Erwin Schrödinger once talked about this, and he said that living systems are able to eat entropy, negative entropy, and thereby delay or reverse decay by taking in food, in effect, which is negative entropy. They can rebuild their bodies faster than the decay processes, and that's why they maintain, for a certain time, avoid death. So these concepts that Prigogine was working on, how a small fluctuation in a reaction medium can grow and produce an ordered pattern, is actually, you find these concepts encoded in the zodiac symbolically.
Symbolism.
And, astrologers, if they didn't have knowledge about Prigogine's work, they would have missed it. You don't find this in any astrology books.
That's the thing, Paul. I always find that, and I look at astrology from a systems approach too. It's how I actually got into astrology. And I said to myself, in an engineering way, I mean, I looked at astrology, and if I was to listen to just the astrologers, I would say, what are you guys talking about? It's like there's too much jargon in there, and not that there's anything wrong with that. I get it. I get that they have a way of explaining their information, but I looked at it in a holistic way and said, okay, if there's something to this, it's got to be measurable and quantifiable. And I said to myself, well, I'm a Cancer. What makes me different to the next guy who's a Cancer? And what makes this Gemini different to this other Gemini? And it's like, and I looked at the system of knowledge, and I seen there was a better way to maybe look at it or explain it. And just in terms of the system of knowledge and the way it's presented. But I have no doubt, Paul, that astrology and a lot of stuff in ancient times has a lot of technology and a lot of knowledge. The knowledge base, maybe not technology, but the knowledge base is there. The knowledge base is there, and it's very, very sophisticated. And I can't explain it, how it's there. That's the thing. I can't explain it, but I know it's there.
Anyway, the thing is that the physics was developed first on a scientific basis, and then I was finding these connections later, which lead you to understand that others had this physics before us.
Yeah.
And the physics has made so many predictions now. It's called subquantum kinetics. So many predictions that have been verified that I have no doubt it's correct. Initially, I was very tentative about it, sort of afraid to be forthright about it. But now, it really has a great track record. And it's described in also my book, Subquantum Kinetics.
A systems approach to physics and cosmology. I'm actually going to get a copy of this because I don't have this, Paul. This looks awesome. I guess, Paul,
if people buy it through my website, etheric.com, and get the third edition.
Third edition here, yeah.
But also they get the fourth edition free, which is the ebook.
Oh, awesome.
It's only sold through our website. And a lot of people end up buying through Amazon, the third edition, and they never find out about the fourth edition, which is like quite a bit of an expansion on the third.
But, oh, wow, this is awesome, Paul. So self-organizing wave patterns, replacing the fragmented and self-contradictory framework of modern physics. How many other people are looking at this in this way, Paul? Is it just yourself, or is there a handful of people?
On subquantum kinetics?
Yeah.
You mean, or
subquantum kinetics.
Well, I guess tens of thousands or hundreds of thousands of people know about it because I've it's been in existence 30 years, and I've been lecturing about it for at least 20 years. And, I get emails from people from all over the world who are fascinated about it, including people in physics departments and engineering departments, students, in some cases professors. So, and there's, for example, the idea that the universe wasn't created by a big bang, that there was continuous creation, is something that there are a lot of astronomers that don't really believe in Big Bang.
I don't either. I'll put myself in the hat too. I just think it doesn't work, does it? I think Hawking's trying to get away from that as well now.
Well, in his black hole theory. He's now saying, well, maybe light can escape.
I know, he's like done a bit of a U-turn on us, but
yeah. That's another concept that subquantum kinetics says shouldn't, is a false concept. Because stars can never really collapse into a black hole for two reasons. One, the fields are not singularities at the center of particles, which they would have to be in order to form a black hole.
Sure.
They've done studies of particle scattering, studies of protons and neutrons, and the field plateaus in the center. So that if you brought those together, the force crushing them together would go to zero if they were close enough.
Sure.
So there's no incentive for them to form a black hole. Then the other thing is that there's enormous energy that would be generated, that's generated continually inside of stars, that is not on the charts of standard physics, and that's called genic energy. And because as soon as you go into subquantum kinetics, you're dealing with a universe that's an open system. Instead of a closed system, it's one that's powered continually by undercurrent of etheric transformation, sort of almost alchemic-like, sort of like what Chinese philosophy talks about, the Tao, the yin-yang. They visualize the ether like a transmutational flux, very much like what Heraclitus talked about.
Sure.
So, yeah.
On the cover of your book, I want to mention this guy. You've got your latest book, Secrets of Antigravity Propulsion, which is a fascinating read. There's so much in there, Paul. There really is. But on the cover, you got Mr. Tesla here. Tesla's UFOs and classified aerospace technology. What a compendium, Paul. What a compendium of, that's like it's a history or encyclopedia, as well as the exploration of the science involved as well. Tesla was a major proponent for the ether as well. I think he was up against it with a lot of people as well. But what a genius brain Tesla was. I think he demonstrated that the ether was there. I personally think he did. I think we may have lost a lot of his technology though.
Yeah, and the way he spoke about it, we have some quotes from Tesla where he spoke about the ether. And he spoke of it in a sense of more the Eastern view. And it turns out it's very compatible with subquantum kinetics. If I discuss, for example, subquantum kinetics with Tesla, he'd say, "You've got it." We would have agreed completely.
Wow.
The idea of materialization, dematerialization, all this is covered in this etheric approach.
Wow. How did Tesla try to exploit the ether? Maybe you can just explain this, because he was trying to tap into the ether, Tesla. Maybe give us a couple of examples of how he was trying to tap into the ether to exploit the energy.
Well, he had his magnifying transmitters. He was dealing with pulsing to communicate energy from one place to another. To actually create energy, you mean?
Well, no, not to create, but to tap into it, or extract it from the ether. Is there a way to harvest what we think of harvesting energy? Is it the same thing?
Well, the way I look at it is this way. See, we've been trained to think of in terms of energy conservation, that in order to generate energy, you have to burn something or consume something that has energy or a fuel. And that's a false concept, what it comes down to. It works, but that's not the only way.
Yeah.
And for example, the table in front of you, people don't realize this, but they take it for granted. Why is that table continually there? Why doesn't it disappear? Now you may think, why, this guy is hallucinating to even think this way. But we take
my table's there.
Because the table is there doesn't mean, you see, that's the way physics is. The framework of physics is configured, conceptualized to say, okay, all that is a bunch of particles that once they come into existence, they're there. Well, that might not be the case. when you get into the ether, you realize, at least with subquantum kinetics, that there's a flux going on, that if that flux were to slow 1 iota, that table could vanish. The ether would still be there, but that waveform would diminish, go to zero.
Wow.
That thing could disappear. And it's the basis of the Philadelphia experiment that was done.
Which is here, and I've been reading, Paul. I think the Philadelphia experiment, I mean, there's a lot of confusion around the Philadelphia experiment, but I personally think it was a definite thing. I think there was an experiment going on, and I think they covered it up as best they could, and I think it went wrong. But maybe you can just give a little bit of background on the Philadelphia experiment, if you could.
It happened back, I believe, if I'm correct on the dates, 43.
Something like that in the 40s, yeah.
Yeah, and I get into the discussing it from the standpoint of Townsend Brown's involvement. He was working in the Navy at the time, and he was in the area of minesweeping research, and he had something like 50 PhDs. Now, why would you have 50 PhDs working on minesweeping? It doesn't make sense.
That's a massive project.
You know, that was the cover. And right before that, we find out that he was in charge of bringing $50 million in gold from England to the U.S. to fund some operation. And it turns out later you find that this research he's involved with required about $50 million. Now that was 1/4 of the Defense Department budget at that time. If you figure what that amount of money was
in the 40s, that's with inflation, that's incredible.
Then we find he was located for a time in now. I'm trying to recall what I had written years ago.
You're fine, Paul. You're fine.
Now, we get this information from his resume that was posted online. And something was also in the Norfolk area, as I recall, for a little around that time. Now, we get this information from his resume that was posted online years ago, and you could get it from, well, his daughter had was giving out documents, or a friend of hers, I guess, was providing documents about Townsend Brown.
Sure.
And you could get this information back then. Then, for some reason, the Navy started changing information about Brown, like when he came out of the Navy. And changed the date so it was actually you wouldn't believe that he was working on the Philadelphia experiment because he wasn't even there.
Wow.
So I mean, here they were trying to apparently cover up this by making changes actually in his credentials.
And we know that's protocol for big ops, Paul. We know that's a big op protocol, you know. Tie it off, cut it off, cover it up, and make it happen, and make it so it didn't happen.
He was actually one time asked by Richard Moore whether he had worked on the Philadelphia experiment, and Brown didn't respond, but he did say much of what's been written about it is exaggerated. So the fact he didn't deny it.
Wow.
Suspect. And I believe the version that is written by one author, which I cite, his name doesn't come to mind, where they were talking about pulsing, doing like pulsing shock waves discharges that would repeatedly creating this field, sort of like basically Tesla wave type shocks. In fact, there's suspicions that Tesla was involved too. Mm-hmm. And to understand, I believe this version because it's understandable in subquantum kinetics what's going on, that they will be able to actually modify the gravity potential with these shocks.
Wow.
And in subquantum kinetics, if you can raise the gravity potential, you can bring a situation of invisibility, theoretically.
Wow.
Where the object would start to partially dematerialize, at least the wavy parts of the particles would start to subside and become transparent, so light could actually go through. And I think that this is what they were doing. And the whole thing was so shocking to them, I believe they felt it should be highly classified, probably for good reason. I mean, we don't want people playing with this technology.
I mean, it sounds extremely exotic, but you know, when you look at the physics of what's possible, it's not really exotic. It's possible, and yeah. I mean, but is it something you want to be experimenting with? Like, I mean,
well, not the average guy, you know. Definitely not.
Tell us about Townsend. I mean, he loved the ether physics. I mean, I looked at some of his diagrams in here for his spinning disks and his anti-gravity and stuff. I mean, this guy was pretty intelligent guy. Like, this guy was on top of his game. Like.
He was a genius. He started when he was 10 years old, experimenting with Coolidge tubes. These are X-ray tubes they use in the dentist office. And he found it moved whenever he'd energize it. So he thought, well, this might be a way to get to Mars. So he wanted to go to Mars when he was a kid.
Wow.
And his parents funded his hobby because he came from a well-to-do family. So Brown was born in 1905. And by the time he went to college, he went to Caltech.
Mm-hmm.
And he was probably only, 17 at the time. So a little ahead of his time.
Incredible.
And was a Nobel laureate there who he wanted to demonstrate his device. He had created by that time this gravitator that every time he charged it to 100,000 volts, the pendulum would swing. Sort of like, what Nasikas was doing with his thruster, but this was using high voltage.
Wow.
And Millikan didn't want to come to the demonstration. He thought this was baloney because it violated or challenged what Einstein was saying, because everyone knows that you can only have gravity attracting, you can't have a gravitational repulsion or things moving spontaneously in their own gravity fields.
Sure.
So Brown was miffed, and he actually, for that reason, transferred to Kenyon and then to Denison, I believe, in Ohio, where he met Biefeld, and they did some more experiments. Eventually, he had his own laboratory, and he was then in the Navy for a while. And there's some work, I understand from talking to a Black Projects guy, that has been classified to this day that Brown was involved in the Navy. Now, whether he was talking about the Philadelphia experiment or something else he was doing, but Brown was for a time with the Naval Research Laboratory. So he had very strong Navy connections. They highly respected him as a scientist. And then in the 50s, he started building these flying discs that would go around like a maypole type of thing. They were discs he would electrify with 50,000 volts and would produce ions in the front and back, plus and minus.
Mm-hmm.
And he got these to the point where in 54, about 53 or 54, he demonstrated them at Pearl Harbor. Large discs, like 3 foot diameter, that flew around the gym.
Wow.
And there were several generals present at a demonstration. It's rumored, this was published in Interavia magazine, which is an aviation magazine back then. It was rumored that these were going hundreds of miles an hour in this gym. And the results were immediately classified at that point. Then you find him in Paris. He's doing some more experiments with a French aviation company Meanwhile, British company or think tank, Aviation Studies from London, they're promoting his electrogravitics. This is the idea that there's a connection between electricity and gravitation.
I'm glad you mentioned this, Paul, the electrogravitic model. Let's explain that for the audience the best you can. I know it's a bit sciencey, but this is still not really accepted today, yeah?
It's not taught anywhere in physics departments. To learn about it, you have to go to the internet or read my book.
Wow.
And Tom Vallone has a book, too, on electrogravitics. You see, it challenges Einstein, makes Einstein look like an idiot. I mean, he knew about Brown's work because they had met during the work that Brown was doing with the Navy. Said.
Sure.
And it's probably the reason he was trying to find a unification of electricity and gravitation, because here he knew about Brown was doing this stuff. And how come his theory wouldn't explain it? So this was torturing him until he died. And he's trying to come up with a unified field theory, but never really had anything. Even today, the unified field string theory, predicts, okay, there might be unification, but it's at particle energy so high we need the CERN collider to investigate. And if you wonder why are they spending billions of dollars with CERN, they probably think that they will find out about electrogravitics by doing it that way, a theory.
Yeah.
I mean, that's the expensive way to do it. In fact, I have a quote here from that.
Yeah, I definitely think CERN's pumping a lot of money in it the hard way. And I think there's great minds out there, and there's great research that has been overlooked in the past, Paul, and it's like being ignored or not treated properly. And I think it's the sign of intelligence. The sign of intelligence is to hear another person's opinion without, even when it's not even if it's in direct opposition, and I think that's a great thing. And I think that if you want to, put research on the shelf and say, I don't like that because I don't believe in it, it's like you're just alienating yourself from possibilities. It doesn't mean you have to go and believe everything. You can still listen and talk to people and explore knowledge, but I don't see that amicable transfer of knowledge, but especially not with electrogravitics.
Well, the nice thing about subquantum kinetics, it offers a theory to explain electrogravitics. In fact, that's what brought me into electrogravitics, because my theory was predicting that protons would create gravity wells and electrons gravity hills, which means that electrons should be antigravitic in effect, produce gravity fields like that would repel the Earth's field in effect. I said, well, this can't be right. And I started questioning my own theory. It's too bad, that all matter doesn't produce the same gravity field, but it happens to be correlated with charge in my theory. And plus and minus. That just like you have plus and minus charge, you have plus and minus gravity potentials.
Sure.
And that theoretically, if you could separate the charges, like you do on a capacitor, like Brown was doing, you would produce a gravity gradient between the plus would have a gravity well and the negative would have gravity hill, and you create a gradient that would then propel the capacitor. And this is exactly what Brown was doing. So when I heard about Brown's work, I realized, wow, maybe my theory is right and physics is wrong. And they haven't been able to explain this with standard physics, and that's why they don't accept it. It's not taught in physics classes. So, and in fact, Brown was working on an ether theory of his own. In his theory, he had something like the K constant was variable somehow and causing these effects. Also, Douglas Aircraft was developing an ether theory, and they were involved in electrogravitics. They had their own ether theory. And this came out through a leak. Documents were leaked at one point. And in fact, I was talking with the fellow who he leaked the information about the B-2 bomber charging the leading edge of the wing and putting the opposite ions in the exhaust. And this fellow was working on black projects, and he got fed up with all the classification and felt that some of this should come out because it would benefit society. And
Wow.
and actually that was where his leaks were published in Aviation Week and Space Technology, which I think later they would joke with it, calling it aviation leaks. Space technology.
Wow.
But based on what they wrote, I realized that this is Brown's technology, and I put two and two together, and then I ended up writing a paper about how the B-2 works. Basically, reverse engineered the propulsion system on the B-2.
Sure.
And that's now as a chapter in the book, in the Secrets of Anti-Gravity Propulsion.
Sure.
But I did call up this fellow. At one point, I got in touch with him through the editor of the journal. He called me up. We had a long discussion, and he was telling me about in the black projects what it's like, that they don't use physics. They consider it, as he put it, classical, outdated.
Yeah. Well, that was my next comment, Paul. Is I personally think that there's a whole think tank of ether physics going on in black ops programs. And that they're tapping into everything they got. And I think it's so far advanced, and I think it's really far advanced than what we got, Paul. I mean, how much further advanced do you want to say? People say we're always 30 years advanced in the military more than the public. And I call it maybe 50 for all. I don't know. It could be more.
Even 50 years, if this time warp freeze of knowledge continues in the physics community, it'll be a lot longer before we get to where they are.
Yeah.
This fellow did mention that they were working on ether theory. They interpreted the ether these things. And that's the only way, really, feasibly to understand these things.
I know Tesla's documents were stolen when he died, and well, there's a lot of debate about that, but I definitely think they took his documents and just seen what he got left, and I personally think they took Tesla's remaining ideas, and I just think they've really just run with them in black ops programs. I really do. I think there's a lot of evidence to suggest that.
And physicists today, they use the euphemism quantum vacuum when they talk about space-time, the etheric aspect of it.
Yeah.
So they talk about zero-point energy. Now, I agree with the zero-point. That's one concept I'll agree with.
Yeah.
The subquantum kinetics explains how it's generated, whereas in physics, it's sort of a postulation. It was the theory that was suggested. Subquantum kinetics, it's a requirement. It comes out of the approach.
Wow.
Without it, subquantum kinetics would be wrong. This shows the rigorousness of subquantum kinetics. There's a lot of predictions that it makes that if they weren't true, then you couldn't do the approach.
Sure. Paul, we're coming up to the top of the hour. I want to make sure you give me a little mention on your website, but we were talking today about the secrets of anti-gravity propulsion, Tesla's UFOs, and classified airspace technology. It's a complete investigation of the development and suppression of anti-gravity and field propulsion technologies. It's a thick and fascinating read. If it's like it's a compendium, and I think it's a definite one for the shelf, Paul, to come back to as a research document as well as an interesting read. Paul, give us out your websites again before we wrap things up. I want to make sure and mention again the project that you're working on one more time for us, and where people can help out, where people can get involved or donate or see the research.
Etheric.com is the one website. Starburstfound.org is the other. We'll probably be putting postings on Starburst Foundation website of our progress with this. So once we get Kickstarter funding or Indiegogo funding, we'll probably use Indiegogo. It will be some months before all this happens as far as building this. But first step is to get the funding. We're hoping to launch this within days to get something posted on Indiegogo. So we need everyone's support to contribute, make this a reality. If you want to have something similar to what Marty McFly was flying in Back to the Future, like that might be possible, or something similar to that, with this thruster that we're developing.
Okay, so that's the Seeker's thruster. I'll tag that Indiegogo. As soon as you got the Indiegogo campaign, you let me know, Paul. I'll put it in the YouTube description box for the people as well, and it'll be also embedded inside the video as well for people. Great to see that, Paul. Great to have an update with you. There's so much in the book. It's really a fascinating read, Paul. Keep up the work, as I can say. It's fascinating what you do. I'm going to get myself a copy of Subquantum Kinetics. It looks really interesting. It really does. And I think there's something fundamental about understanding the universe with what you do, Paul. And I just don't see it. You're going to get that in other places. So I thank you for your time today, Paul. It's been an absolute pleasure.
Thank you very much.
You're currently working on the Nasika's thruster rocket as a replacement for normal rockets. Paul, you got to tell me about this. Expand on this. This is pretty revolutionary, yeah?
Yeah, well, Dr. Nasika is a physicist, was a professor at the Technological Educational Institute of Thessaly, it's called now, and he's now retired. He had been experimenting for 10 or 20 years on propulsion ideas and stumbled on this device that's a superconductor. It consists of a superconductor and magnet that develops a thrust when you cool it.
Wow.
You have to use nitrogen to cool it down. So you're familiar with maglev?
Oh, yeah.
There's like a train in China and Shanghai that runs on maglev, and that works by having magnets in the rails pointing up, and then on the train they have this superconductor, high temperature superconductor that they cool down. And when it becomes superconducting, it's able to repel the magnetic field of the magnet. So it develops a field opposite and is able to levitate the train. So what Nasika has developed is a way of putting that magnet on the superconductor itself, so that it, as a unit, can propel itself through space. So if you were to take it out in space where the temperature is can be 40 degrees above absolute zero,
wow.
It would just accelerate and eventually reach the speed of light if it went far enough. And we've built and tested this. It's a very small thrust, but it's already it's 1,000 times better than what NASA used to go to Ceres with the Dawn spacecraft. The Dawn spacecraft used what's called an ion
propulsion system. Yeah, so it's 1,000 times better than an ion propulsion system
in terms of the thrust per unit mass.
Yeah.
Because the ion propulsion system has to take with it 0.5 ton of xenon propellant.
That's the drawback.
Plus, it needs solar cells, so the weight of the solar panels. And then the thruster itself weighs 15 kilos. Wow. So by the time you add up all that, and
there's a lot of momentum to get that up. So basically, the ion propulsion system, it puts out an ion beam, and it slowly but surely builds up momentum until it's...
Right. It would never get off the ground from here, but you see they build it out in space. And it's able to... With such small thrusts, they can get out there, but it takes 7.5 years. With Nasika's version, he has no propellant, so the thing weighs, compared to over 0.5 ton for the thruster system that they use at NASA, his weighs, it'd take 5 of his thrusters that we test to equal the thrust on the Dawn spacecraft. And that comes to around 600 grams is all it weighs. So
whoa, that's a big
per
difference.
unit mass, his develops 1,000 times more.
That's crazy, Paul. Paul,
But it needs no power because it uses a permanent magnet. Now, the one we're working on that we're looking now for funding is going to completely change the world if it works. And we believe it works. We've done calculations, the physics, the equations for interaction of electricity and magnetism indicate that it will produce this force. It's whereas the first one worked on what's called a Meissner effect, which is using a maglev. This works on a slightly different force. It's called Lorentz force.
Lorentz law, yeah.
And it involves a coil, just a superconducting magnet coil like they use at CERN for their particle collider. But he designs it.
We're missing the big part of the puzzle, and but like I say, there's very few people want to rise to the challenge of a systems theory, because you have to have a spectrum that's very big, Paul, or a knowledge base that's very big as well.
Yeah. Well, this is a core idea in systems theory, is to try to become more interdisciplinary, and that's what systems theory does. Is takes ideas from one field and brings them into another, because it gives you a framework for doing that. And we find, like, for example, years ago, they thought that the human body operated like a machine. And eventually, as science advanced, they found, well, we're biochemical systems. And, the same for business organizations. At one time, they sort of directed businesses as if they were military organizations. Yeah. And then with system theory actually made inroads into the theory of businesses, and they started looking at them as organisms.
Wow.
Competing.
Self-organizing.
Sort of the same principles that operate for cells and for living organisms can be applied to businesses. With physics, it's sort of like stuck in a time warp in the past.
For sure.
It's like froze, like in Matrix, they froze everything.
Yeah.
And the real advances have gone forward in black projects, secret projects that we have no idea about, unless there's some leaks here and there.
Yeah. I want to get into some of your recent projects too, but just on that point, Paul, do you think when there's black projects going on, that these guys have got the free reign? They're the real think tank. They're just given the big budget and the free reign to go and explore whatever they want?
Well, I can't really say.
You can only speculate.
But I imagine that's probably could be close to it, what you're saying.
Sure. Today's author and researcher, Paul LaViolette, and we actually have met before at a conference in Bosnia, and fascinating guy. We had lunch together. Paul is one of the greatest minds in this alternative research, and fascinating to have him on today. I don't want to get complacent. A little bit about today's author before I bring him on. Paul LaViolette, PH.D. He's the author of Secrets of Antigravity, Propulsion, Subquantum, Kinetics, Earth Under Fire, Genesis of the Cosmos, Decoding the Message of the Pulsars, Galactic Superwaves and Their Impact on Earth. He's also the editor of A Systems View of Man. He's also published many original papers in physics, astronomy, climatology, systems theory and psychology. He's received his BA in physics from Johns Hopkins, his MBA from the University of Chicago, and a PhD from Portland State University. Currently the president and director of the Starburst Foundation. You can find that website starburstfound.org. And you can read about Paul's bio and on his other website, the etheric.com. That's ETHERIC, etheric.com. Without further ado, let's bring on today's guest. Hi, Paul. First of all, you're very welcome to the show.
Hi, how are you doing?
Good, Paul. Great to see you again. We met at the conference in Bosnia. I had been aware of your work before from a couple of people who brought it to my attention, and I found it fascinating with the Galactic Superwaves, and I know that's been a heavy hitter as well, and across the board. I guess, Paul, I mean, it's not the normal branch for people to go down in physics, and if people want to check out that interview, you can go to Paul LaViolette, Capricorn TV, you'll find that Paul's presentation, but I just found something really deep and meaningful in your work, Paul, and I know that you have a great mind the way you look at it, and there's not a lot of people take on this subject matter. I guess tell us a little bit about you, Paul. Why physics? Why? I always want to know about a physicist. Why does a physicist jump into the physics? It's always interest to me. What inspiration? What encouragement? What support?
Well, when I was very young, I was just curious about everything. Existence, the whole thing. And that's what I thought physics would teach you, was to understand the physical world around us. And really, probably what I was aiming at was what I got into later, which was system theory, because system theory deals with everything. It combines science with philosophy, almost. And the system theory's made great advances in business, sociology, life sciences, across the board.
It doesn't discriminate.
When I got into physics, I was disappointed, actually, that, they were focusing, a lot on theories of what was happening at a level they couldn't even see. And it wasn't really giving very satisfying explanations to me. And that's when I started searching outside physics for other ways of looking at things.
Sure.
And finally ended up in systems theory.
I think there's something awesome about, I worked as a systems analyst, but mostly in an engineering place. And I know we talked about that, Paul, in Bosnia, but I just love what that, it took me a long time to get there. I elevated myself to that, and I know exactly what you're talking about, Paul. It seems bizarre that we have these compartmentalized subjects where we look at a very narrow window and we think we're the greatest expert in that, and we're sometimes missing the good stuff, or